What if medieval cathedrals were not just places of worship, but giant musical instruments made of stone? Imagine architects drawing circles with compasses, measuring perfect ratios, shaping massive vaults for beauty and sound. Today, we decode the hidden geometry where stone meets sound. In the Middle Ages, architecture was deeply connected to mathematics. Builders used simple tools, a compass, a straight edge, ratios. They relied on geometric forms like circles, squares, and equilateral triangles. These shapes represented harmony and divine order. In Gothic cathedrals, such as Notre-Dame and Chartres, proportions were carefully calculated. Height, width, and length often followed musical ratios similar to those used in early sacred music. To medieval thinkers, math was the language of God. Now here is where it gets fascinating. Large vaulted ceilings do not just look dramatic, they shape sound waves. When Gregorian chants echo through a long nave, the sound reflects off stone walls and curved ceilings. These reflections blend together, creating long reverberation times. The result is a floating layer sound that feels almost infinite. The building does not just contain music, it transforms it. Certain points inside cathedrals create surprising acoustic effects. Stand beneath a dome, speak softly. The sound travels upward, then returns amplified. In some cathedrals, whispers can be heard clearly across distant points due to curved surfaces focusing sound waves. These are not accidents. Architects understood how curves guide both light and sound. Vaulted naves act like acoustic funnels. Apse curves concentrate resonance near the altar. It is geometry performing sound. Medieval builders were influenced by ancient ideas linking music and mathematics. Simple ratios like 2:1 or 3:2 define musical harmony. Similar proportions appear in cathedral dimensions. When sound waves match spatial proportions, resonance increases. Long stone corridors amplify low tones. Tall ceilings enrich sustained notes. Gregorian chant, with its slow and steady rhythm, fits perfectly into these echoing spaces. The architecture extends the voice beyond the human body. Imagine standing inside a cathedral at night. A single chant begins. The note rises, reflects, multiplies. You cannot tell where the sound ends and the building begins. This was intentional. The goal was not just worship, it was immersion. The design created an emotional and spiritual response through mathematics and physics. Stone, space, and sound merging into one experience. Today, acoustic engineers study these cathedrals and confirm their extraordinary reverberation times. Some spaces sustain sound for over 6 seconds. Modern concert halls use advanced software to design acoustics. Medieval architects achieved similar effects using only geometry and intuition, no computers. Just ratios.